Hello, everybody, and welcome back to our last lesson in Chapter 6, Acid-Base Chemistry. This is another one that carries forward into Chem 30. We do all of these same topics with a little bit extra in our Chem 30. So knowing this well in 20 will really help you out for those who are going on to Chem 30. So today we're going to look at polyprotic acids and bases. So these are chemical compounds that, as the definition says, can react with water more than once to produce hydronium ions. So they're a little tricky, and what it means is you have successive reactions, first one and then the next and then the next. And the best way to explain it is to really look at some examples. Phosphoric acid is one that's used in pop to give it a little bit of zing. I've used it before to remove rust from cars as well. You can buy a concentrated phosphoric acid at Canadian Tire. It's a good way to try and remove some rust. It didn't work as well as I had hoped, but it was okay. So here's our weak acid, H3PO4. You recognize that it's polyprotic because of the H3. So what that's telling us is that this acid has 3 protons that it can donate, and we like to show it in successive steps because each proton is donated a little differently. So the first proton as a weak acid, the rule is less than 50%. So less than half of those protons are donated to make hydronium and H2PO4 minus. Now H2PO4 minus is also an acid, because it has 2 protons that it could donate. So we're going to start the reaction again. This time it's the H2PO4 minus that is going to react with water and donate a proton to water. Now my question for you is the following. Which one do you think is a stronger acid? H3PO4 or H2PO4 minus? Which one do you think is stronger? And if you guessed H3PO4, you would be correct. So these are donating a proton. And if you think about it, this already has a minus charge. So how easily will it let go of an H plus if it's 1 minus? Not very easily. So the rule is if the first proton is less than 50, the next one is less than 5%. So very few of these H2PO4 minuses will donate their protons to make hydronium. So we get really a very small amount of hydronium ions on that second proton donation. And we've lost an H, so we're down to 1. So HPO4. And we were at 1 minus, we lost the H plus, so now we're at 2 minus. Now, if you look at this one, it has 1 proton left to donate. So we can do a third donation. HPO4 2 minus, aqueous, can react with water. Oh boy. So what percentage of these do you think will donate their protons? If they're at 2 negative, how easily are they going to let go of their last H plus? Looking at the trend, give me the number, and it is 1%. Less than 1%. They're getting weaker and weaker and weaker. So that's weak. This one is weaker, and this one is the weakest. Okay, it's like the Goldilocks theory, the 3 bowls of porridge. Weak, weaker, and weakest. Okay, so we do get a very small amount of hydronium ions produced, and the last anion left over is a PO4. It's lost the last H, lost the plus, 3 minus. And if you check charges, they are balanced. We've got a 2 minus. And here we've got a 1 plus and a 3 minus, which gives us 2 minus. So charges are conserved or balanced in that reaction, and you can check them all. They're all good. Okay, so important for you to remember this drop in percentage, less than 50, less than 5, less than 1, getting weaker and weaker as we go. All right, we'll look at one more example. This is an interesting one. Polyprotic acids are all weak except this one. So as you know, there are 6 strong acids. H2SO4 is the only polyprotic strong acid. It's the only one. So of the big 6, it's the only one that is an H2 or an H3. So H2SO4. So because it's a strong acid, how many of its protons will it donate to water in its first reaction? Strong acid, correct answer is 100%. So the only polyprotic acid that donates 100% of its first protons, and that would make hydronium and HSO4 minus. Okay, so now if you had to guess, this one's polyprotic, so it has the second proton to donate. So we've got HSO4 minus. And that one can react with water. What percentage, if you had to guess? First one is 100%. What's the next one? If you guess less than 50, you would be correct. H3O plus, and we lose another H, so we're down to SO4, 2 minus. Okay, there's the unusual one. 100%, less than 50% on the second. All of the other weak acids are like phosphoric. Less than 50, less than 5, and if they have a third proton, less than 1. Okay, second half of the lesson is polyprotic bases. And right now you're thinking, holy smokes, another short lesson. I love this. Okay, polyprotic bases can react with water more than once to produce hydroxide ions. So these usually come in the form of X2 minus or X3 minus. So a 2 minus can gain 2 H pluses and a 3 minus can gain 3 H pluses, making them good bases, or at least polyprotic bases. So here's the first reaction. It's a weak base, so it is going to be less than 50%. There's why it's a base. It's taken 1 proton from water to make OH minus, and there it is with the 1 proton. Now, because HCO3 has a minus charge, it can still act as a weak base and accept another proton from water. So it can take 1 more because it's a minus. It'll take that H plus, or it can take it. So if their first one is less than 50, the second one is less than 5%. So we get a very small amount of hydroxide forming on that second one. Oh my gosh, my computer's just bogged right down. I noticed the internet really slowed down for me in the last hour. That must mean you guys are all up and awake and working on lessons. This one's being recorded late in the afternoon. Okay, OH minus, and what's left over? So it has taken another H plus, so now it's H2. CO3, and it's taken another plus, so it's neutral. It's gone from -1 to 0. So there's our second acceptance of a proton to make a second hydroxide, and again, much smaller percentage on that second step. So that's what a polyprotic base looks like. So to summarize, polyprotic acids are weak acids whose reaction with water decreases with each successive step. Greater than 50%, greater than 5%, greater than 1%. And that's if it has an H3 to get to that third step. Sulfuric acid is the exception, which we went through. Greater than 99 on the first, less than 50 on the second. And polyprotic bases are weak bases. And same deal. Their reaction with water decreases with each step. So less than 50, less than 5, less than 1. And you're going, we didn't see any triples. An example of a triple would be PO4, 3 minus. A 3 minus could react with water 3 times. I'm not going to go through all of them, but here's the first one. HPO4 2 minus and hydroxide, and then the HPO4 2 minus could react with water. Wow, that is so messy. And you could continue on. Okay, so to practice this in your textbook, there are only two questions on polyprotic bases on page 259, numbers 7 and 8. And that's it. And you have your final assignment and quiz for chapter 6. So my advice would be try these two questions, and then you can move on to the final quiz and assignment for chapter 6. So I'm going to stop there. And if you want additional practice on all of the chapter, there is in your study guide a review assignment, page 226, 227 for Mrs. Kelly and 222, 223 for Johnson. And I will put the answers on Google Classroom for that, so you can check. They're really good questions for you to do, and they'll help you to get ready for that final assignment, final test on Chapter 6. Okay, take care, and next time I see you, we will be starting Chapter 7, Stoichiometry, and Chapter 8 combined, which is our last unit, and it's not that long, so as I said, we will be done early. Yay! Have a good day.